AI again.
Now, one of the things that I read that was fascinating to me was the idea that you also, the optometrist gave you special glasses that redirected the light in different paths so it hit the retina in different ways in order to trigger the non-visual image processing capability of the retina. And I was just fascinated by that light on the retina could be a signal that's interpreted differently in the brain. So the retina was doing more than just getting the images of what's out there. It was helping you with the actual cognitive function.
Absolutely. And you're very astute in picking that part of the book out. Of those 50 million computers that we say is roughly equivalent to the human brain, about half to maybe 80% are the estimates get involved in visual spatial processing at some point.
Half to 80%.
50% to 80% of our brains are the estimates that I've seen at some point get involved in visual spatial processing. And this means we are primarily visual spatial beings. And I can give you an example of that. If I were to stand behind you, Kevin, and tap a wine glass behind your right shoulder and tear a piece of paper behind your left shoulder, that even though you're using your ears to interpret these signals, you have a great deal of spatial information that is immediately available to you, that you translate this 3D hearing spatial world into visual spatial signals in the brain.
So I can picture the glass and I can picture the paper.
And not only that you know it's a glass in one case and paper in another, but where they are in relation to one another, where they are in relationship to you, who you are, where's up, where's down, and also that you can drink the glass and you can write on the paper. All of this is instantly available because it's highly visual spatial information, and we're talking about what's coming through your ears. We haven't even addressed the eyes.